Hey students, in this video I'm going to go over the Unit 9 review, and if it's too long I'm going to also break it into two parts. So part 1 should be the front, which is transformations, and part 2 will be the back, which is solving equations. Alright, so this first example right here, it gives you the parent function of e to the x power, and then it gives you a new function with a number in the front, with a negative, and a minus 5 at the end. So for the template of e to the x, we have the a value, then we have the b value, then we have, it's a, and then the base of e, and then these two are multiplying each other. And then the exponent, you will have the b, x minus h, and then plus k. So right now we can see that the -2 in the front will be an a value, and there's nothing on the exponent other than x. So it's just looking at the k value now for that -5. So two descriptions, actually three descriptions we have here. We have what happens when the a value is negative, and what happens when the a value is 2. So when the a value is negative, we talked about how that will be a reflection, and you just have to decide if it's over x or over y. And the best thing to do is to graph it and see what happens. So e to the x power is the parent function. And then if you put a negative in the front of that, look what happens. So it reflects it over the x-axis. If it would have been over the y-axis, you would not have had the negative in the front. You will have had it in front of the x, like that. And that will reflect over the y. But we don't have that. So we are going to write that the description is over the x. All right, I'll come back to that. So reflects over x-axis. All right, another description here is the number 2. What happens if we put a number 2 in the front? So right now I'm going to put a 2 in the front and see what that does. And if we look at these two functions and compare, e is the original, 2 is the new one. We also need to recall that if it's an a value, we're going to describe the change as vertical, and then b value will be horizontal. So because the a is on the front, it's an a value, we're going to say it vertically either stretches or compresses. And with a rubber band, we can see how this original graph, the blue one, will have to be stretched vertically and not compressed. Stretch pulls it up, compressing pulls it down. So that will be a vertical stretch. Vertical stretch by 2. If it was a b value, you'll have to say by 1 over b, so it would have been 1/2. But because it's an a value, we just say by the number that it is. All right, the last part is what happens when we have a k value that is -5. And you can either go by the anchored chart on Instagram or just type it in right here. We have the parent function, and then we're going to put -5. But be very careful. This -5 right here is in the exponent, and this is what happens when I have it in the exponent. And if I was to not put it in the exponent, it will look like this. I will put it on the bottom, and it will look like this. So two different things happen if you don't type it correctly. This is the correct version. The -5 or -5 is after the x is an exponent, not on the exponent. Oops, sorry. So we're going to say it shifts down 5. All right, the next part is writing down the domain and the range for g of x, which is the new one. So if we put all this together, I'm going to put that -2 in the front and then -5. This is how the new one looks like. I'm going to zoom out a little bit just so it could look a little bit better. And we realize that the horizontal asymptote shifted down when the graph shifted down as well. So now the asymptote is at -5, and I'm just going to graph that for you. I'm going to put y equals -5, and then it creates that horizontal asymptote at y equals -5. So because this graph is not a great grid, I'm just kind of I'm going to dash right here at -5, and I'm just going to curve. So it could be like a sketch that is down here. So domain, left to right, it is -infinity to +infinity because it's going left and right forever. We can also write it as the set of all x values such that x is an element of all real numbers because it's all the values left and right. Left and right. Range, we're looking at it up and down. Minimum is the lowest, maximum the highest. But when we write it here in parentheses, we still want to have the minimum on the left, maximum on the right. So minimum here is this graph going forever down. So it's going to be -infinity. And then up, the highest it could go is where the asymptote is at. So that's -5. And we don't put a bracket, we leave it as parentheses because it's an asymptote. So it's never touching that point. Also, if you analyze your graph, you can go to table. Make sure you color coordinate correctly your graph. This is a red graph, so we don't want this table. We want the red. So press to the right, and here is your red. So notice how the numbers, if I go down, they get more negative, because they're going down to infinity, -infinity. And if I go up, notice that the numbers are getting close to -5, but they never become, well, it looks like it gets to -5 right there, but it's just not higher than -5. But this graph is, again, there's an asymptote at -5. All right, so next, I'm going to do the one below. You can practice the one on the right side and talk to me in class if you have questions or if you want me to check it. Here on this one, we are going to, again, look at the parent function. And then this is a new function. And just again, recall where the a value is. A is in the front. Log base 2 is your base. And then you have b, x minus h plus k. So if you compare this to what you're given, you're not given an a value, you're given a b value. However, it needs to look like this, b parentheses x minus h, in order for you to correctly identify the h value. So we're going to look at this, -4x plus 12, and maybe rewrite it here above, -4 being the GCF between these. And then you will have x minus 3 as your x minus h. Negative times negative is positive, so this is the correct version of the new written version of that bx minus h. And then this is your k value, so we're going to talk about what the k value does if it's -2, what the b value does when it's -4, and what the h value does when it's 3. So we're going to have 4 descriptions when b value is negative and when it's 4, and the h value when it's 3, and the k value when it's -2. And I know you see -3, but I'm only circling 3 because if you look at the template, it's x minus h. H is by itself, not including the minus. So here the 3 is by itself, not including the minus. All right, so let me clear my calculator. And then let's go ahead and graph it so you can verify what each one does. And again, you can go by the anchor chart on the Instagram page or graphing it. So I'm gonna hide the grid. I don't know why the grid appears. All right, so we're gonna write log base 2 of x. So that's your parent function according to this. That's the one you start with. And then the new one, we're gonna play with it to see what all these things do. So we're gonna retype the original one, so log of base 2 with the x in there. And let's try b with the negative first. If there's a negative right there, this negative, what is that going to do? And then this is what it does. So it's a reflection across the y-axis. And also, if you recall from the previous example, this was a negative for an a value, so it's across the x-axis. This is a b value that's negative, so it's across the y-axis. Next, let's talk about what 4 is doing. I'm going back to editing that one, and instead of -4, I'm putting a negative, I'm putting a 4 just by itself. So if I compare the original to that one, I need to describe it and recall that b values are descriptions that are horizontal. So whenever you do write your description, you want to talk about if it's a horizontal stretch or compression. Your original is this blue one, and in order to make it look like the red one, this is what horizontal stretch is, and this is horizontal compression. So for it to go higher like that, it's a compression because you're pushing it in sideways. So that will be a horizontal compression. And you're going to say by 1 over b. So you're going to say 1/4. So keep that in mind. When it's b value, you're going to say by 1 over b. All right, next we have an h value that is 3. So we're going to write this again, and now delete the 4 in the front. And -3. So this is what the 3 does. It shifts it to the right 3 spaces. The vertical asymptote has now shifted along with it, and it has an asymptote when x equals 3. Now, if you for some reason forgot to do the GCF here and you graph this, it will still show you that it shifted 3 spaces. So I'm going to show you that. I'm going to put it the way it is. And notice how this, if I remove the negative, it'll just be facing the other way. But as far as shifting sideways, it was only 3 spaces, not 12. So keep that in mind, graph it, and verify what the shifting left and right is. And if it doesn't seem right, like if 12 is not how much it moved, go back and double check if you need to do this, if you need to do the GCF. So shifted right 3. All right, and then let's finish it by checking what the k value does. So if the k value is -2, this is what it does. So it looks like it's still going the same direction, but it just kind of dropped a little bit. So it reminds you that the k value is the up and down description, and it shifted down. Okay, so those are the descriptions for it. Now, as far as the domain and range, I'm going to go ahead and put everything back again. And this is what it looks like. And we need to recall that the vertical asymptote shifted 3 spaces along with the h value. So now your limitation is here at 3, not at 0. And it's going left. So I'm just kind of create a vertical asymptote here at 3. So we remember that that's our limit. And then it goes to the left. And it could be a sketch that's wrong because it looks like it's touching around 1 and 2 on the y-axis. But again, it's just a visual for me to help you do the domain and range. Left is going to go forever, and this is going to go down, approaching the asymptote, but never touching. So it's stopping at 3, the highest on the x-axis. So domain going left to right, we're going to have negative infinity, but stopping at 3 with parentheses on the left and right. And then the x, the set will be x such that the x values here are less than 3 because anything higher is not being used. So we're going to say less than 3. We're not going to say equal to because the asymptote exists at 3. And also, if you go to the table, you're going to notice that here, well, I guess I'm in the wrong graph because this is the blue one and we want the red one. So let me switch. Notice all the errors that exist right there when the x are positives. And then as it approaches below 3, it starts giving you values. So anything up to 3 is your domain. For the range up and down, again, you want to start with the minimum, maximum after. Minimum is the lowest, maximum is the highest. The lowest that this graph goes is negative infinity, and the highest that it goes will be positive infinity. And that means your set notation will be y, such that y is an element of all real numbers. That reminds me that on the example above, we didn't write the set notation for the range. So I'm just going to go ahead and go back to that. Y values such that y is, and again, the limit here was -5 or anything lower than that. So we're going to say is less than -5. All right, so this short video just goes over transformations one more time. And again, practice with the 2 examples on the right side. And let me know in class if you want me to check them. All right, thank you.